Health outcomes. Changes due to interventions. To bring positive change, patient experiences and health must both improve. Healthcare costs must be lowered, and clinician and staff burnout has to end. But our problems are big. 133 million Americans have at least one chronic disease. 500,000 people are dying every year from hospital errors, injuries, and infection. The shortage of primary care professionals will be as much as 100,000 in just the next 5 years. Big problems require bigger solutions. Positive change needs acceleration. It needs to happen now. But these are not so easy solutions that many don't want to hear, and even few are willing to talk about. How to lead such a change? How to discover, discuss, and disrupt healthcare to make a difference now? This is VITALS, Visionary Health Leadership in Action.
Good afternoon. I'm Dr. John Langell, President of Northeast Ohio Medical University, and I'm pleased to welcome you to VITALS. VITALS is an online and in-person opportunity to meet with our nation's transformational healthcare leaders who are using the tools of VITALS: value, innovation, technology, advocacy, leadership, and service to transform the healthcare landscape for our patients and our communities by improving healthcare. I'm pleased today to bring you one of our very own graduates, Dr. Crystal Mackall. Dr. Mackall is a graduate of 1984 Northeast Ohio Medical University, then Neo-UCOM. She is the Ernest and Amelia Gallo Family Professor of Pediatrics and Medicine at Stanford University, founding director of the Stanford Center for Cancer Cell Therapy, associate director of the Stanford Cancer Institute, and director of the Parker Institute for Cancer Immunotherapy at Stanford. During her 27-year tenure at the National Cancer Institute, Dr. Mackall held multiple positions, culminating as chief of the pediatric oncology branch and head of the immunology section. Since 2016, at Stanford, she has led an internationally recognized translational research program focused on immune oncology. Her work has advanced understanding of fundamental immunology and translated this understanding for the treatment of human disease with a major focus on children's cancers. She has received numerous awards, including election to the National Academy of Medicine, American Society of Clinical Investigation, and American Academy of Physicians. She is a fellow of the American Association of Cancer Research Academy. She received the Smalley Award for outstanding contributions to cancer immunotherapy from the Society for Immunotherapy of Cancer and the American Association of Cancer Research St. Baldrick's Distinguished Achievement Award for Pediatric Cancer Research, and the Nobility in Science Award from the Sarcoma Foundation of America. Dr. Mackall has published over 250 manuscripts. Her H-index in January 2024 was an amazing 104, and she has co-founded 4 biotech companies based on multiple patent filings. An amazing and transformational leader, Dr. Mackall, the floor is yours.
Thank you, John. Really a pleasure to be here. Not really back home, but in spirit back home. So I am just delighted today to be one of the distinguished speakers in this VITALS series. It's really an inspiring series. I wasn't aware of it, and now I am. And so hopefully I can follow it after today as well. So as John said, I graduated from Neo-UCOM in 1984. I hail from Northeastern Ohio. And in my 17 minutes, and let's hope I make it, I'm going to try to do 3 things. A little bit of a walk down memory lane, because that's what people do when they get older. I'm going to share with you the reasons why I am incredibly hopeful that immunotherapy will forever change the course of cancer medicine, and hopefully you will share with me in that enthusiasm. But on a more maybe less happy note, I then want to share the reasons why I am very concerned about the lack of drug development in pediatric disease compared to adult disease, and why I'm putting energy in that direction. So I'm going to start and share my screen, and let's hope everything goes as hopefully everyone will be able to see that in presenter mode. Okay, let me know if there's a problem. So I thought I'd start with some pictures from my time at NeoUCOM, but given that we didn't have internet back then, it actually was kind of hard to find a lot of them. Here is a picture of me with some of my classmates on the Rootstown campus, probably around 1980. I found this picture of me sitting next to something that I think we called a word processor back then. I like to tell my students that I started my career back in the last millennium. I actually wanted to highlight Norm Paradise, because I got my first taste of bench research in Rootstown, working in Dr. Paradise's physiology laboratory. And in fact, this was my first scientific publication. So very formative for me. Let's see if we can get the next slide. There we go. From my very early days in medical school, I knew I wanted to be an oncologist. I was always drawn to the challenges in the field. In my mind, it was a field that required both top-notch clinical care, but also deep scientific understanding, complicated disease, and it required a willingness for the physician to really bond emotionally with the patient and the family. I always liked challenges, and for me, oncology was the most challenging of all the fields. My hard question that I couldn't really answer, I had difficulty answering, was whether I wanted to do pediatric or adult oncology, which were then and are still today very different worlds. So I undertook a combined residency in internal medicine and pediatrics at Akron General Medical Center, as it was named at the time, and Akron Children's Hospital. And I was there from 1984 to 1989. And during that time, I was heavily influenced by several wonderful oncologists who were clinical mentors to me. I want to highlight Joe Kostelic and Carl Krill at Children's, and Sandy Hasbro at Akron General. Each of them had the skills and the talent and the commitment that I wanted to emulate. They were also really very curious scientists in their own way, who were not afraid to connect emotionally with their patients. Now, I remember vividly in 1985, during my residency, reading this article published by Steve Rosenberg at the National Cancer Institute. And this was like nothing I had ever seen before, because this was a cancer treatment that didn't go after the cancer. Rather, they administered something called interleukin-2, which causes T cells to grow. And when they administered the interleukin-2, 11 of the 25 patients had regression of their cancers, meaning that the immune system could actually control cancer. And at this time, there was a small number of scientists who believed in this, but the vast majority of the oncology field thought that this was something that was not worth pursuing. Well, I found a like mind at Akron General, Suo-Ling Chen, a PhD working in the immunology laboratory. And Suo and I started to do some research on the side while I was a resident. Of course, there wasn't much time, but I found this graph in my files where we had grown lymphocytes from patients with colon cancer and looked at their relative growth rates and their ability to kill cancer. By the end of my residency, I was very locked in on not only doing oncology. I wanted to do research related to immunotherapy. But I also made the decision at that time, to become a pediatric rather than an adult medical oncologist. And I think about, why I did that. And in 1989, if you were an adult with cancer and your tumor couldn't be cured by the surgeon or the radiation oncologist, the medical oncologist was not likely to be able to help you. And in fact, you were likely just to suffer at their hands. Because the chemotherapy we were administering was very toxic. Nausea, vomiting, hair loss, anemia, fatigue, neurotoxicity, all of those nasty things we know about chemotherapy. And for all that toxicity, we weren't able to cure these patients. But if you were a child with cancer and you saw your medical oncologist, which was a pediatric oncologist, you had about a 70% chance of being cured. And it did require usually some combination of surgery, chemotherapy, and/or radiation. And while the children did experience some of the nasty side effects, they were resilient, and we were able to deliver cure rates in the 70% range, which seemed like a more promising space. And so I then moved on in 1989 to pursue my fellowship in oncology, and I chose to do it in pediatric oncology. But I also wanted to certainly undertake scientific training. And so I went to the National Institutes of Health, which was one of the few places doing cancer immunotherapy research. And there I undertook 3 years of clinical fellowship and another 6 years of what I call postdoctoral scientific fellowship. So if you look at it, there was a lot of training involved, another 7 years after my residency. Now, luckily, after I completed these fellowships, and I say luckily because any scientific career that is successful, there's always a bit of luck involved. And luckily, in 1996, when I completed my fellowship, there was a leadership change in the pediatric oncology branch. And I was given a small amount of space and a tenure track position and the opportunity to conduct my own independent research. And so I did that at the NIH from 20 years there, you can see. First as a tenure track investigator, then a tenured investigator, and as Dr. Langell said, ultimately as chief of the pediatric oncology branch. And what my time at NIH really taught me was the power of conducting both caring for patients and conducting clinical trials alongside bench research, and communicating between the communities that are doing this work in a way so that we are continually learning from our patients and from our laboratory studies. The momentum and the synergy that you can get from this iterative back and forth, bench to bedside and back, is unparalleled. I learned to do it at NIH, and there was no better place to do it, I think, than NIH at that time. And so this is really the theme I still use today. Now, we became very interested, as I mentioned, in immunotherapy, and in particular, this type of immunotherapy called CAR T-cell therapy. And this is just a little sort of animation that I give you to show you what we're talking about here. So here you have lymphocytes on the left and nasty cancer cells on the right. And the idea is that the cancer cell is going to grow and outpace the lymphocytes. But if you are able to insert a gene that can train the immune cell to go after the tumor, and this gene integrates into the genome, so it's not just in the cell that you treat, but all the daughter cells, then what you have now is an army of immune cells that can serve as killers. They can divide and multiply and conquer and really eradicate the tumor. Now, it seems a little bit like science fiction. So you'll believe me. Here's a picture of these CAR T cells that we took in the lab. The red cells are the cancer cells, and the little round cells are the immune cells that basically become an army and get rid of the red cells. Look at that again. You start with these nasty big red cells, and you see all these cancer killers come in and be able to eradicate the tumor cell. Mother Nature's T cell is not able to do that as well as these engineered cells that we were able to generate in the lab. And so here's an example of using those engineered cells. These are targeting a molecule called CD22 that were developed in my laboratory. And here we're treating now children who had acute lymphoblastic leukemia, the most common cancer of childhood, whose disease did not respond to all of the great standard treatments that had come down the pike over the last, 40 years. These therapies had failed these children. And so each line here represents a different child. And you can see that we're looking at the change in marrow blasts, and those that go down to -100 here have a complete response to the therapy. And you see that we have a 70% complete response rate in these very difficult to treat diseases. So by 2016, it was clear to me that CAR T-cell therapy and cell therapies for cancer in general were going to move out of the boutique and research institution, government hospital environment, because they showed so much promise. And these were going to become real therapies for real patients at hospitals all over the world. I often think about my training in community hospitals, and I think that our work isn't done until our therapies that we develop can go back to those community hospitals and cure patients there. So I wanted to be part of this real world rollout, and I wanted to continue to contribute. So I left NIH to go to Stanford to build the Stanford Center for Cancer Cell Therapy to develop next generation engineered immune cells programmed to search and destroy cancer. I did that because Stanford has an amazing both scientific and clinical infrastructure, and they also had invested in a good manufacturing practice facility. This is basically a factory that the investigators ourselves, we can use to manufacture these cells for clinical trials, allowing us to do this outside of biopharma. So through our Stanford Center for Cancer Cell Therapy, we've seen some very significant activity. And I want to show you this video that we have on our website for our center at Stanford, which I think really gets to the bedside and shows you how powerful and how different this is.
Cellular immunotherapy is a new way of treating cancer. It's really completely different than anything that you can imagine when you think about giving medicine to treat cancer. We take the cells from a cancer patient and we engineer them. That means we put a gene into the cell so that all the daughter cells also have.
Okay, so are you guys not seeing the video?
No.
Okay, darn it. Well, I'm going to stop that then. But basically what this was showing was a patient who was receiving the cells at the bedside, and the physicians actually administering it. And what we often see is that the patient really feels that this is part of their body that has been engineered. We often see families pray over the cells, have priests come in, and they really feel like this is their chance to go after their tumor. And again, it's a completely different way of thinking about poisoning the tumor, or poisoning often the patient. Okay, so our cellular therapy program at Stanford has been very successful so far, in that we've had, been able to provide hope for patients who come to us being told that they have incurable cancer. Here's a PET scan of a patient that received a double CAR that we generated in our lab, and you can see all the widespread lymphomatous disease and a complete response there. Here's another patient that had large intra-abdominal disease, had never had a remission with any of her previous lines of, I think, up to 5 salvage therapies she'd received. And you can see she has a complete response to the therapy that we developed in the laboratory. Here is her with my colleague David Miklos 2 years after her therapy, looking very, very healthy. And this is a graph showing how well these cells expand in her bloodstream. Of course, we're also doing this intensely for children. And we've seen some really promising results, both in the leukemia that I mentioned, but we're also moving towards solid tumors and brain tumors. And in some cases, we collect the cells from the child's arm, just as we do adults, and infuse them back into the vein. But the other thing that we've learned is that you can actually deliver these cells directly into the central nervous system through an indwelling catheter, let's say a shunt or an Ommaya catheter. And we've seen some very remarkable effects in brain tumors. This is arguably the most lethal cancer of all. This is diffuse intrinsic pontine glioma, a disease for which there are no active therapies beyond palliative radiation. And all of the children, most of whom are school-aged when they're diagnosed, this happened to be a 16-year-old, a little bit adolescent, really they all die. And we discovered that these cells express high levels of a target that we could make a CAR to. And here's an example of a patient who had a very nasty pontine tumor, had a complete response to both intravenous followed by intracerebral delivery of these CAR T cells. This is now his normal fourth ventricle, and all that's left there is the residual of a biopsy tract. He went from being wheelchair bound and homebound, a treatment entry, not able to go to high school. He's now independently attending college. Now, certainly every one of our patients, no way, experiences this good of a response, but this gives us hope. And we've had a very significant benefit in 9 of the 11 patients treated in our first cohort. So we're at a point where there is really lots of reason to be hopeful. And I'm hopeful that we've finally been able to come up with new ways to treat children's cancer. But I want to sort of step back a minute and take a look at the lay of the land for adult oncology versus pediatric oncology. What we're seeing, and these are commercials that I see in the evening when I watch TV, that demonstrate the immense progress against adult cancers that we're seeing in 2024 as a result of biopharma investment. This is for Verzenio, for breast cancer. Here's the cancer patient looking at the stars. Opdivo plus Yervoy. Here you don't really know which is the cancer patient. They're feeling so well and doing so well, you can't even tell they're under cancer therapy. Here's another example from Pfizer. Again, you think she's the cancer patient, but you're not sure. And this is really something to be celebrated. This is directly downstream of the war on cancer from 1972, basic fundamental research, and the handoff to biopharma. Things are working as they should. Here's the pediatric story, however. Now, you're not going to see biopharma advertisements because biopharma doesn't invest in pediatric cancers. But what you will see is St. Jude, one of the greatest pediatric cancer hospitals in the world, delivering state-of-the-art therapy. And you know very well that these children are undergoing cancer therapy. They don't look particularly healthy. They look scared. Their parents look scared. They're in the hospital. This is showing the very difference in which we live. And so even though we are making scientific progress and developing exciting new therapies for pediatric cancer, I am very concerned that they are not going to make it to market because we have a square peg round hole problem. Biopharma's perceived obligation is to maximize return on investment, and return is, measured in dollars and cents. Cell and gene therapies are these types of therapies. They're more expensive to develop than other therapeutics. So it makes this mismatch even worse. What biopharma tends to want to do is to raise the price to offset the small market size, but that's not a sustainable approach, and it's already limiting access to certain subsets of children in the United States. Here we have pediatric diseases that are poised for major impact using cell and gene therapies. We've got extensive investment in this space that have been made using public monies, using your taxpayer dollars, NIH, Department of Defense, etc. But what we're seeing is a market failure. These are not making it to the market. Now, we believe that pediatric cell and gene therapies can provide a positive return on investment. It's just never likely to be maximized. So we're now thinking about business models, and we step back and we say, look, who pays for what? If you look at the innovation pipeline, public monies, nonprofit, and biotech and pharma pay for all of these amazing advances that allow new therapies to come down the pike. And as you get into early clinical testing, you still have a mix of company investment and nonprofit public investment. But by the time you get to pivotal trials and FDA approvals, it's all driven by biotech and pharma. And that means that for pediatric diseases, we don't get the investment and we end up with a market failure. And so our question is whether we can create a new entity that can address this market failure and commercialize these therapies for pediatric diseases. And so now we're starting to think about creating, we're calling it a pediatric advanced medicines biotech. And this would basically be the entity that would take the handoff from academia. Once the investigators make a discovery and show a signal of efficacy, we would do the work that biopharma normally does. And we would take this new agent to pivotal trial readiness. We would conduct the trial. We would file it with the FDA, and we would ultimately commercialize it so that it could be delivered in pediatric hospitals across the United States. And I hope we have some time in the question and answer to talk about how and why we think this is possible. But I'll stop there. Thank you very much.
Thank you, Dr. Mackall. We'll have you unshare your screen. There you go. Thank you again. And for those watching along and who have joined us in the past, I am not WKYC Senior Health Correspondent Monica Robbins, but I am filling in for her today as she's dealing with a case of laryngitis. So we certainly send our well wishes to Monica. Hope she feels better soon. I am Dave Vitito. I'm the Senior Director of Alumni Relations, and it's an honor to be pinch hitting today for Monica, but also to do so with one of our graduates who we point to as a transformational leader. So again, thank you, Dr. Mackall, for being with us today, but also for the example you set for our current and future students. So what do you say we get into some questions? We've had a few submitted ahead of time, but we also encourage anyone watching along to submit your questions in the Q&A feature, and we'll get to as many of those as possible. So are you ready, Dr. Mackall, for the first one?
Yeah, let's do it.
Wonderful, wonderful. The first one is, can you share the importance and impact of translating your research through commercializing your research, and what have you learned? How has this changed your approach to research? Yeah. And should we train future physicians in the process of inventing and commercializing their discoveries?
No, Dave, that is a really great question. Thank you. So, if you look at the phases of my career, I kind of divided them up because they had different impacts. And at NIH, for better or worse, we had very little interaction with biotech. We, in fact, weren't really allowed to consult with biotech. We could file a patent and then biotech could license our patent, but we had nothing to do with it. It was all behind a closed door to us. And so I learned so much about taking a therapy from bench to bedside, which is critical. And it's, absolutely the first step. But I learned nothing about going to market. And I realized when I got to Stanford that you're only halfway there. As long as your therapy is being delivered, even if it's gangbusters and great, as long as it's only being delivered on a research study, you're not getting that therapy to all of the patients who need it. And you're going to run out of money because the payers, ultimately need to foot the bill. Research is expensive. It incurs excessive costs. So what I learned since 2016 is that you want to partner with biotech, you want to partner with pharma, or you want to figure out how to commercialize on your own. This is where this radical notion that we could do this in the United States outside of the for-profit sector. But you got to get these things to market by hook or by crook. And that's where I've spent a lot of my time and energy. There's a lot to learn there. And I think you do want physicians in that space. So to the extent that, the medical school training and the postgraduate training will provide insights into that world, all the better, because it's part of the drug development pathway, just like basic science or clinical trials.
Thank you. And you may have just touched on this a little bit, but to build on that, is it possible to create an entirely new model to commercialize pediatric therapies outside of traditional biopharma?
Yeah. This is the idea that we are currently working on. We might fail. I mean, one of the things I've learned in my business is if you don't take risks, you don't get anywhere. And so I try to get young people not to be afraid to fail. There's nothing wrong with failing. Sometimes you fail because it's not the right time. Sometimes you fail because it wasn't a good idea. I mean, you need to understand why you fail. But at this point, I'm still at the phase where I'm totally accepting of the notion we might fail. But I think it's possible. And I think it's possible, especially for these cellular therapies, because we are able to manufacture them in academic medical centers. In fact, currently, we teach the companies how to manufacture these cells. We actually create the intellectual property, then we give it to the for-profit sector using an exclusive license that then doesn't allow us to use it, and they don't develop it for pediatrics. So this system needs to change. And it may be that we will continue to need some public monies for this. It may be that we continue to need philanthropy. But I think we can get a few of these over the finish line and then use that revenue to keep the whole program evergreen. People call me an eternal optimist, and maybe I am. So again, I'm finding folks who are joining with me on this vision. And by the way, our colleagues in other countries are already ahead of us on this. They've already seen the fact that these cell therapies are so doggone expensive, and they can make them for more cheaply in their hospital laboratories. And so in some ways, I think the US is a little bit behind. But things will need to be different in the US than in other countries, because you really need to work with your FDA and your EMA, and that's different in different countries. So I think we can do it, but we'll see.
That actually was the next question. How are other countries dealing with the market failure that we're witnessing for pediatric drug development? Can you elaborate on that a little bit more?
Yeah. I mean, I think Europe is probably, of course, not one country, but travels together on most of the drug development areas. And I think they already understand the idea of government funded entities. Of course, they have nationalized healthcare, and so they see it as the responsibility of the government to solve these problems. And I think that's a disconnect in the States, where there is, a greater feeling that the market needs to solve the problem. And I'll tell you that most pediatric oncologists that you'll talk to, and me even, in years past, we end up basically getting angry. We think that why aren't companies doing the right thing? Don't they care about children? Won't they just make the right decision if we just lower the bar? I mean, there are plenty of incentives that are out there for companies that have been put forth by the FDA, for instance. And what I've learned from, again, working more closely with biotech is it's not about these people not wanting to do the right thing. It really is a model that everybody agrees on, that, private sector companies, the goal of their goal is to maximize return on investment for the shareholder. And nobody argues with that. We're not going to change that. And so I've stopped being angry, and I've started to try to understand where they're coming from and how we can work with them to solve the problem. And I'm fully convinced that biotech and pharma want to solve this problem. They don't like the idea that pediatric cancer medicine is so far behind adult cancer medicine. And if we are able to create some models that will not, that will fit into both of our worlds, I actually think we're gonna get buy-in. For instance, one of the things we could do with our nonprofit that we're proposing is we could actually run the clinical trials that biopharma is required to run based on FDA mandates. We could run them, and they could pay us for that. We would do it more cheaply, and we would do it more efficiently because we understand the pediatric space. And that would be another way that we stay evergreen. So we just have to be creative and entrepreneurial to think about how we can get capital investment from what segments. And we need good therapeutics. We can't, we have to, bet on the winners.
Thank you. Looking ahead, what treatment breakthroughs do you see possibly on the horizon for childhood cancer at this point?
Yeah. I mentioned that chemotherapy actually works better in children's cancers than it works in adult cancers. And that's been a blessing and a curse, because the truth is cure rates are not that bad, 84%. It sort of depends. If you happen to be in the 16%, it's pretty terrible. But, it comes at this huge cost. And what we've learned, we didn't know this in the 80s when we had these 70% cure rates, but now that we follow these patients long term, what we've learned is that while the patients are cured of their cancer, they've traded their cancer for other diseases. And so survivors of childhood cancer are not living normal lifespans, and their rate of late effects don't seem to plateau. They just seem to increase with time. There's almost a premature aging that we see in these kids. And so chemotherapy is one of these things that we just need to, I don't know if we'll get rid of it, but we need to reduce it to the fullest extent possible. Now, there's the whole age of targeted therapies, which really dominated the 2000s before immunotherapy really came on in 2010 or so. Targeted therapeutics, like some of those that are the advertisements you've heard, the pills that you take every day, they haven't worked in children's cancers. Now, you can say that's bad luck, and some of it may be bad luck because the biology is different. On the other hand, the drugs were made because they worked in adult cancers, and that's why we targeted those molecules. If we had a whole biopharma enterprise to target the genes that were aberrant in pediatric cancers, we might be further. So I don't think that the first wave of targeted therapies is going to have any major impact. And so we're really banking on immunotherapies for children's cancers. Even in the immunotherapy space, the most common immunotherapies and the most effective so far are checkpoint inhibitors, the Opdivo and Yervoy, and Keytruda. Those also haven't worked in children's cancers, sadly. So that's why we are really relying on these more complicated therapies, these cellular therapies, and these antibody-derived therapeutics. They really are showing some pretty incredible promise. So I'm very excited about cellular therapies showing progress. There probably is likely going to be another wave of targeted therapies come down the pike using so-called degrader technologies to be able to modulate the levels of proteins in cells. And it's different than targeting kinases like the first wave did. And maybe those will work in children's cancers too. I hope so. We need more than one shot. We can't just have one class of therapeutics because cancer is too wily for that. But even if we had a degrader, we still need to figure out the way to get these things to market, because just because they work in the test tube or even in an early phase trial, it doesn't mean we would get them over the finish line.
Okay, I want to pivot to maybe one or two questions for the next generation of health professionals, researchers out there, certainly in the neomed community with our students. But Dr. Mackall, you spent 27 years with the National Cancer Institute before joining Stanford. What was that transition like? You did touch on it a little bit, but the NIH Institute to academia, what advice would you give someone making a similar transition?
Well, yeah, and Dave, I'll even back that up a step, because the bigger transition was going from Ohio, neo-UCOM, and Akron General and Akron Children's to NIH, because I hadn't done much research, and I hadn't grown up in a world where fundamental research was the front and center. So I was an outsider, and I think that one of the most important things for young people to understand is that we all sometimes feel like an outsider. You can look at your peer next to you and think, geez, that guy has so much confidence and looks like he or she has it all together, and I'm lacking in something. And ultimately, if you believe in yourself and you're willing to put in the hard work, you'd be surprised what you can accomplish. Was I intimidated? Sure. I was intimidated, but it would just make me double down and work harder. And one of the things I came to learn is that I did bring a sense of fearlessness with me. I didn't come from a place where the expectations were so high that sometimes that can strangle people too, sort of the albatross of expectations. And so I think everyone's narrative provides an opportunity. And I always tell folks, own your narrative. You are who you are, and that wherever you came from, if you came from a place where you had a hard scrabble life and you had to really pull yourself up from the bootstraps, well, guess what? That made you a tougher person than maybe somebody who had it a little bit easier. That doesn't necessarily put you at a disadvantage. So I think, working on yourself and figuring out how you can bring the confidence that you need to accomplish whatever goal it is. I don't know if we spend enough time having folks, really do that kind of hard work to, give them sort of the confidence and the wherewithal. But, I always am very thankful to NIH for giving me a chance, even though I didn't have research experience, and for training me to be a scientist. And then moving from NIH to Stanford was kind of fun because, frankly, they underestimated me, They figured NIH was some kind of, I don't know what they think. It's funny, the West Coast doesn't, they don't think about the federal government very much. I don't think they have a very good understanding of it. And so it actually has been a very fun transition. I've learned a lot from Stanford, but I think they've learned a lot from me too. I bring a very practical approach, and I think that hails back to my neo-UCOM roots. I always tell people I was a physician long before I was a scientist. And so at the end of the day, science for the sake of science, it's fine, and we need it. I understand that. But what I'm doing, I'm trying to make something that will actually, change the future of medicine. And I think we get a lot of buy-in when we just lay that out there. Because after all, most of the investment in science comes from the taxpayer. And the taxpayer is looking for a return in terms of, how is this going to help me?
Thank you for that. We had another question prepared geared towards advice for students, but I think the way you package that addresses that question. So we might move on to some of the chat feature Q&A questions that we're receiving. First up, do you think that you have faced additional challenges as a female clinician, scientist, and leader in medicine? And if so, how did you learn to navigate and address them?
Yeah. Interestingly, in the early days, I did not feel it. I really didn't. I never felt any kind of sexism at neo-UCOM or in my residency training. I was only ever treated with, the utmost of respect, and I never felt any kind of discrimination, I guess would be the word. When I got to NIH, I also didn't feel it until I started to move up the ranks. And as I moved into positions with greater resources, you want to use the word power, it makes people nervous, authority, what have you, I started to be concerned that there were some decisions that would be made that didn't make sense to me. And, some of my female colleagues also felt the same. And so, yes, I think that, this exists, and, I experienced some of it. Obviously, I was able to work around it. And again, at Stanford, I have felt none of that. It's kind of fun to watch at Stanford because, it's like about, I don't know, something like 40% of the chairs are female or something. And don't quote me on that, but there are a lot of women in leadership positions. And yet I've been to, a few, women faculty luncheons with, university presidents. And the women are holding their feet to the fire saying, now listen, the number is only 40%. And what is happening? And it's true. We are still seeing fall off as women move from assistant professor to associate professor. It's absolutely true in academic medicine. So there are still problems. I think the culture at Stanford is very positive in that regard. I am worried though, really at the fall off between the junior faculty and the senior faculty. And we're all very much, concerned about how do we stop that trend? And I think some of it comes down to figuring out how to balance family life and these, very demanding jobs. My life partner, Dr. Catherine Salem, who we've been partners for 44 years, also graduated from Neomed. We raised 2 children and, we shared the household duties. It was really a 50-50 share. And without that, there's no way that I could have done what I've done. So some of it is the institution needs to provide space for women and understand that they need to have babies and they need to raise children. And some of it is also that, in the home, women need to be, shared responsibility.
Thank you for covering that ground. That was another question that came up about the work-life balance, how you address that, how, with your busy schedule. So thank you.
Well, I don't know if I completely address, let me, because that one, there's a lot more to say there.
Sure.
So let me take that a little bit. I work really hard, but I have never felt that work was the most important thing in my life. And I have always made a conscious decision to put whatever it was first. I know I'm looking back now as I was raising my kids and all that, we put the family first. You have to make a decision, otherwise you become schizophrenic. Like, there's always these conflicts, like I'm supposed to be here, I'm supposed to be here. If you understand in your mind, this is what's most important, it's easier to make those decisions. I find that now that I'm older and the kids are grown, it's my health. I can't push myself the way I used to. And either I take care of myself or, I run out of gas. So I think it's important, again, this gets back to the doing the self-work that it takes to keep you a sane, happy person. Because if you work so hard that you no longer have that feeling of belonging or feeling of healthfulness, everything else will fall apart. So I think sometimes there's a guilt between this work-life balance, or that somehow you're not giving it your all. I actually think that's wrong. And you need to be kind to yourself, because we want you in it for the long haul. And UCOM is putting a lot of investment in you, and the whole infrastructure is, and you gotta keep yourself healthy and psychologically at the ready. So the only way to do that is to feed the whole person.
Also wonderful sentiments for our students. Thank you for that. We'll switch back to more some questions about your work and your research. What non-cancer disease states do you believe will be impacted by CAR T-cell therapy?
Well, funny you should ask, because this is one of the the signals you will start to see from biotech this year, especially because CAR T cells are now starting to show signs of activity in autoimmune disease. And so that's very exciting. I'm not an expert in autoimmune disease. And my guess is that this is very expensive and, has some toxicity. I mean, toxicity is relative. When you're talking about, someone dying of cancer, the toxicities of CAR T cells are very clearly, the risk benefit falls in favor of treatment. If you're talking about a benign disease, benign being non-malignant, of course, if you have very bad autoimmunity, it's not benign. It's just that you need to be careful that the toxicities are not so bad. Patients are still getting chemotherapy, for instance, 1 dose for CAR T cells. So, We are also, there's some long-term potential risks of malignancy that the FDA has just flagged. We think it's, less than 1 in 1,000, but it's something to think about if you're treating a non-cancerous disease. So, but I do think we're going to see some patients with severe autoimmunity benefit from CAR Ts. The other thing that's important to understand is that CAR T cells have paved the way in the field of cell and gene therapy because they were so effective. And, we've now treated probably in the States about 35,000 patients with CAR T. So lots of experience now with giving cellular therapies. They've paved the way for other cellular therapies and other gene therapies. So we just saw the approvals for sickle cell disease that came down in December. Those are still, the market hasn't, we're not getting that out to all the patients who need it. And I think patients aren't sure yet if they want it. But we're going to see these kind of cellular therapeutics become important for the treatment of immunodeficiency and other diseases. And then the whole field of gene therapy. We're seeing diseases like muscular dystrophy now get early FDA approvals, and hemophilia. Diseases that you couldn't even think about, curing before. CAR T cells have paved the way for all of that because they were the first cell and gene therapy to become a medicine, to be approved by the FDA, for instance.
Thank you. And we're approaching the end of time here. Maybe time for 1 or 2 more questions. And there's so many wonderful questions in the Q&A section here, so I'm getting to as many as possible. Next one is, what can be done to increase participation of minorities in pediatric cancer treatment clinical trials?
Yeah. So we have been following that and thinking about that. We being, the larger community, I think very intensely just in the last 5 years. It is something that I think we have all recognized, just as pharma has really developed drugs using adult cancer as the model. The new therapies that are developed are largely enrolling Caucasians. And so they've been optimized for benefit in Caucasians. And often you will see novel therapeutics not have equivalent benefit in, minority populations, ethnic or racial minorities. So the first thing we have to understand is, we have to understand the biological difference, and we have to figure out, if there was access, would the patients want it? At Stanford, I think you can't talk about minorities as one monolithic group. A large proportion of the patients we treat with leukemia are Hispanic because their leukemia is actually higher risk in general. And in fact, we have an overrepresentation both in our pediatric and adult studies of Hispanic patients because they need it and they are willing. On the other hand, African Americans, we have had very low enrollment. And I think that this is in part because Stanford hasn't made itself available to the African American community in the Bay Area. And so I think, we have to think about these communities as communities. And, it's not going to start with research. The first thing you're not going to do with a community is say, hey, come on my clinical trial. What you first need to do is to build trust, and you need to deliver your proven therapies in that community in a way that's accessible to them and affordable to them. So it's about building trust and building relationship, and hopefully the trial enrollment will follow. But everybody in the whole enterprise has to make this a priority. We are seeing widely disparate outcomes, both mostly in adults, I would say. More so even in pediatrics, between African American patients and Caucasian patients, and it's really the house is on fire. We need to figure this out. So thanks for bringing that up. We have a lot of work to do.
Absolutely. Maybe one final question, see if we can fit it in here. Do you feel the FDA innovation initiatives for rare diseases are working? The FDA is supporting Pediatrics Medical Device Consortia. Does something similar exist in the cell and biologic space?
Yes. Yeah. What's the acronym? I'm forgetting it. I think the FDA's heart is in the right place. Are they doing enough? Probably not. I think that the gene therapy consortia that they have launched with the Foundation for NIH is a great start, but there's a lot more work to do. I don't see FDA as the barrier. I do see them as partners, but there's always more work to do. And I hope that as we come up with our new models for developing these therapies for children, I anticipate that FDA will be a good partner in that. So time will tell.
Dr. Crystal Mackall, thank you. Thank you for your time. Thank you for the amazing presentation and the wonderful insights. With that, I will turn it back over to our president, Dr. John Langell.
Thank you, David. You've done an excellent job. I hope WKYC doesn't steal from us in the future. Dr. Mackall, amazing. We are so proud to have you as one of our graduates and watch with bated breath as your work continues to improve the care of our patients across the nation and across the globe.
Thank you so much.
Our amazing VITALS content is provided by Neomed with the support and partnership of university hospitals. Please remember to file for the free CME if you have an interest in doing so. And please join us for a special in-person and web-based VITALS in April when we'll hear from Dr. Sarah Whittingham. Dr. Whittingham is a professor of surgery at Northeast Ohio Medical University, a clinical anesthesiologist, and a person who was diagnosed with early onset Parkinson's disease. Her inspirational story has garnered national attention over the past year as she uses her role as physician, patient, and Ironman athlete to lead an advocacy initiative to support and improve Parkinson's disease patients, especially in our nation's veterans. Until then, stay engaged and pursue your passion to become a truly transformational leader.
This is VITALS, Visionary Health Leadership in Action.